Okay, today I'm gonna be doing chapter A, question 3 for the examination. Number 3. So let's go ahead with the first question. The first question is giving us a system composed of different particles. They all have different masses and they're giving us two locations of them. They're asking us to find the x-coordinate of the center of mass of the system. So let's go ahead and write what we know. So far we know the mass of particle 1, we know the mass of particle 2, we know the location of particle 2, we know the mass of particle 3, and the location of particle 3. Let me go ahead and write that down. The first one is going to be 0.500 kilograms. Second one is going to be 125 kilograms. And the first location is going to be this. X is going to be 0.150, and then Y is going to be 0.200. This is all going to be in meters. Now the mass for this one is going to be 0.75 kilograms, and the location is going to be 0.200, and the Y is going to be negative 0.800 meters. Okay, so now that we have this, we know that they're asking us for the center of the mass, so we can use the formula for this. So let me go ahead and just write that first. Write it down. It's going to be mass 1, location, and then mass 2 with the x location, and then mass 3 times the x coordinate. The x coordinate. And then this is all going to be over mass 1 plus mass 2 plus mass 3. Okay, so let's go ahead and plug that in. So we have mass 1 is going to be 0.500 times 0 because they didn't give us a location. Then we have this one over here, 125 kilograms plus 0.150, which is going to be the x meters, plus, let me go ahead and move this so we have more space. Okay, plus the third location that they gave us, kilograms, and the x coordinates of this one. Okay, we have that. We know that it matches. Now let's go ahead and write the masses over. It's gonna be 0.5, 1.25 plus 0.7 kilograms. Okay, so I'm just gonna put all these numbers in the calculator, and then when we go ahead and do that, we get that the center of the mass for this system is gonna be 0.1. It's gonna be 0.135 meters. Okay, that's gonna be it for part A. Now let's go ahead and part B. The part B is gonna be the same question, but they're asking us to find the y coordinate. So of the center of the mass. So what are we gonna do? You're gonna use the same formula, but in this case, instead of the x coordinate, we're gonna use the y coordinates that they gave us. So let me go ahead and write it first so I don't get lost. It's just easier. Mass of 1, y of 1, plus the mass of 2, and the y location of 2, plus mass of 3, plus mass of 3, and the y location of 3, over mass of 1 plus mass of 2, mass of 3. Okay, so let me go ahead and plug that in, the ones that we have. So we have the first one. That one is always going to be times 0 because they didn't give us the coordinates. Then the second one, the y coordinate is going to be 0.200 meters. And now for the last one, it's gonna be the mass and the meters, the y coordinate. Okay. And then over the three masses as well, just like we did before. So 0.5 plus 1.25 plus 0.750. And then we go ahead and plug that into our calculator, just like we did in the previous one. And then we get that the y coordinate of the center of the mass of this system is going to be 0.140, negative 0.140 meters. So that's going to be it for part B. Let's go ahead and continue with part C. Okay, part C right here. Let's see what the question says. They're giving us a different one. 3 objects lie along the axis at 3, 1 at their origin. They're giving us another one. They're giving us x coordinates. The center of the mass of the 3 objects. What is the position of the 120 object? So they're asking us to get the position of something. So what we're gonna do in this case is that we're gonna use the same formula that we use, but we're gonna solve for that one position they want us to get. So we're using the same formula with x coordinates, which is what they gave us. They didn't give us any y coordinates at all. So like that, over mass 1 plus mass 2 plus mass 3. Okay, let me go ahead and plug that in. So we know the answer, so let's go ahead and put it. They already gave us what this would give us. So this is that. Okay, we have the first one over here. We didn't have a y acceleration for this one. We have the second one over here. Actually, let me go ahead and put them right here, which is better. Mass 1, so we can see them. Mass 2, location of mass 2, and then mass 3. So for this one, it's going to be 3 kilograms. This one is going to be 2 kilograms, 1.50, and then 1.2. Okay, so let's keep going. Now we have this, and the location was 150 meters. And then for the last one, which is what we're trying to find, we do have the mass of this position. It was 1.20 kilograms, but we need its location. So we're gonna head and solve for that. Okay, let me do this side first. Gonna put this to the other side. We need to put the masses at the bottom as well. 1, 2 plus 1, 2. Okay. Oh, this is a 5, by the way. Alright, now let's go ahead. When we solve this, we're gonna have on this side 0.3 plus, we still have this here, 3. I moved over what we could, and then we are simply gonna get this by itself from algebra, and then we're gonna have that the x location for the 1.20 kilogram one was negative 3.53 meters. Okay, and that is gonna be part C. Now let me go ahead and do part D right now. Part D. Let's see. So for part D, they're giving us 3 glitters or 2 glitters. They're giving us direction. One has moved to the left. Okay, so let me write that down what we know. Okay. We know the mass of the glitter A and the mass of the glitter B. So the mass of the glitter A was 0.25 kilograms. And the mass of the glitter B was 500 kilograms. Okay, for this, in this case, we are gonna use the momentum formula. So let me go ahead and do that. Let me put the formula here. I like putting the formula first just so I don't get lost, because otherwise I do tend to get lost. Okay, now on this side, this one's the same mass of the A glitter, mass of the B, and the velocity of the B. Okay, let me go ahead. So for this one, we're just gonna have 0 and 0 because we only have one mass. So mass of A, B. Okay, and we're gonna solve for how far from the right is the starting position as to the left. How far to the right from its starting position has glitter B moved? So they're asking us for distance of the glitter B. So let's go ahead and get this over here so we can get the right formula, because we have to solve for the glitter A first, and then we're gonna solve for the distance of the glitter B. So when we solve for BA, we're gonna get MB over MA, which is the mass of both of the glitters. Let's go ahead and put that down. So the mass of the both glitters of the B is gonna be 0.5, and the other one is gonna be 0.25. This is gonna be BA. Okay. Now they're asking us to get the distance, so we can use these formulas over here, which is gonna be times time, velocity times time of the glitters. And now let's just solve for distance of the big glitter, which is gonna be this over that, and then this over this. When we go ahead and move that to the other side, we get that DA, it's gonna get 0.96 meters, which is what they gave us, which is what it moved, distance. This is the distance that the glitter A moved. And now we're gonna use the formula that we found, and then we're gonna plug that in to get the distance of B. Then we have this over here over 4. It's gonna give us a distance of the glitter B when he moved was 0.240 meters. This was a bit complicated just because we have to find the formula from the start. Well, we have to solve for something else. So, okay. Let me go ahead and start with part D, since we have it down. So let's see what it says. The 3 objects each have a mass. No far. Initially, the first object, they're giving us the location. They're giving us 3 locations, and they're giving us a location later on. So we're gonna have, this case, we're gonna have initial positions and final positions. So let me go and write this down. Initial positions. They give us X initial, 2 initial, X3 initial. They also gave us the Y locations. So let's go ahead and write those down. It's just better to write everything down so we don't get lost later on. Okay, initial, it's gonna be I had, sorry. Okay, then Y hat, and then this is gonna be 0 J hat, and then L J hat. And then we also have the final positions, so let's go ahead and write those down as well. Final positions, we have the X final, X2 final, X3 final, and then the Y final, y2 final, y3 final. Okay, so let me go ahead and put those down. For this one, it was L over 3, negative L over 3 I had, then 1.5 I had, then X I had. For the Y, we have L over 4 J hat, then we have negative L J hat, and then Y J hat. So let's get the initial coordinates, and we're gonna use the center of the mass. So let's go ahead and put the formula here to get the initial. Okay, we have it right here, and the center of the mass is gonna be just the same one that we have been using this whole time. X2, X3, and then the masses under. Okay, so let's go ahead and we have all of this values, so let's go ahead and plug those in. We have M, then L plus M, L plus L over sum of the three masses. We don't have the masses, so let's put that. So we have 0. And the final let's find the final x coordinate of the center of the mass. So let's go ahead and put that. Of the center of mass. Okay, center of the mass. And let's put the formula that we use. In this case, we're gonna use the final one. Still final mx. And let's go ahead and do m plus m plus m. And then now let's plug that in. We're just gonna use algebra in this case again to get the final value. Plus m, because we don't have the masses, we only have the positions, plus mx over 3m. When we put that and then enter a calculator and we do the algebra, we get L6 plus x. And now let's do the x center of the mass with the final equals the center of the mass with the initial. So what was our initial? Our initial was 0, and then the final was 1 over 3, and in parentheses L plus 6. When we put those together and we solve, we get that the position of the third object is going to be negative L over 6, and that's going to be our answer for part E. Part F now, if I'm not wrong. Yep, we're doing part F. Part F says, find the y position of the third the x position. Now we find the y position of this same object. So we're gonna use the same values that we were using in the last question. And let's go ahead and find the x coordinate now. So we have mass formula, mass with the initial y, mass with the initial 2, mass with the initial 3. And then we have mass. And then let's go ahead and solve this algebra. So we have that 0, we have that this is 0 as well. And luckily we have this one, which is L over 3m. What does that give us? Simple. This just gives us L over 3. And now let's find the y coordinate of the center of the mass, the final y coordinate. So we already found the initial, and then we have to find the final. We'll go ahead and just type it in. The center of mass was M1 final plus M2 final plus M3 final, and then we have mass. Let's go ahead and solve that. Let's just plug it in what we have. Luckily we have some of this. We have that this is gonna be negative L, and then we have that this one is just simply y, and as always 3m because we don't have any mass. Now we get that this is gonna be 1/3 over 3L plus 4 plus y, and then we apply the same formula that we did for the previous one. It's gonna be y coordinate center of mass final equals y coordinate center of mass initial. So the initial one was L3, and then this one was 1/3 parenthesis 3L over 4 plus y. When we solve this for y, which is the y coordinate, we get L. This one goes on the other side, 3L over 4, and then when we simplify, we get that this is going to be 7L over 4. And this is it.